Today we're going to discuss lesson 5.4, solving compound inequalities. So we're going to move from just single inequalities to compound inequalities, which means we're going to have more than one inequality and talk about how those are graphed. And I'm going to kind of show it. It's a little confusing, but it's once we kind of break it down for you, it shouldn't be too bad. So for our first example, we're going to write and graph compound inequalities. So in other words, what that word compound right here means is we are going to be looking at the solution set for two or more inequalities and kind of see where that falls. So it says, first of all, translate the verbal phrase into an inequality and then graph the inequality. So here's the verbal phrase. All real numbers that are greater than 2 and less than 3. Okay, so that word and right here, you should star that. That means it has to follow both items. If you see the word and, it has to basically fall under both categories. Okay, all real numbers that are greater than, sorry, I said 2 first, but negative 2. All real numbers that are greater than negative 2 and less than 3. So we're going to write that like this. So here's my solution set. Here is my x that's going to represent all real numbers that are greater, because remember we kind of can start with our variable when we're reading our inequality. And right here it says that our solution set of x has to be greater than negative 2, which follows this part, but it also has to be less than 3. So that satisfies this part. So when you have an and statement, it has to satisfy both parts. It can't satisfy one or the other. It has to satisfy both. So our solution set is going to be the numbers, obviously, in between negative 2 and positive 3. And here is how we would graph that. Okay? So what I want to show you is we're kind of graphing two different parts. So we're looking at graphing this part individually right here. The x is greater than negative 2. And I'm going to rewrite that over here. X is greater than negative 2. And I'm going to graph this in red. So that would be an open dot right here and a line that goes this way. Okay? So all of these numbers that are lined in red satisfy this part of the inequality. X is greater than negative 2. So all of these satisfy that. Okay, but I'm going to do the second part of the inequality right here. X also has to be less than 3. So I'm going to put an open dot at 3, and I'm going to graph, obviously, all the numbers that go this direction. Okay, the key here, since we have the word and, the key here is finding where they overlap, where both, let me change colors here, where they both overlap, where the red line and the green line overlap. They don't overlap on this dot because this red is open here, and they don't overlap on this dot because the green is open here. So the solution set has to satisfy both parts. So where they overlap is where you have your solution set, which is why just this part is graphed on the line. Because on this side of the line, we only have red. And on this side of our dot, or whatever, we only have green. And we have to only consider where we would have red and green, where they would overlap because of that word and. So hopefully that makes some sense. Okay, so that would be our how we would write this and how we would graph it. So the next one is going to be all real numbers that are less than 0 or greater than or equal to 2. So again, now this time we have the word or. That word or means it only has to satisfy one or the other to be part of our solution set. They only have to satisfy one part, not both parts. So here is what our equation would look like. Okay, x has to be less than 0 or x is greater or equal to 2. So there's our writing, and here is how we would graph it. Okay, because of this word or right here, we don't have to have them overlap. In fact, if we had the word and here, there would be no solution because there is no overlapping. Right here is where x is less than 0, and then on this side is where x is greater than or equal to 2, and they don't overlap at all. But because we have this word or, either one has to be satisfied. So that's why this right here in the middle is left blank, because 1 is neither less than 0 or greater than or equal to 2. So 1 cannot be in the solution set because it doesn't satisfy either of these inequalities. Okay? All right, so moving on. Translate the verbal phrase into an inequality, then graph the inequality. This is your guided practice, so pause the video and please do your guided practice. All real numbers that are less than -1 or greater than or equal to 4. So it's an or, so you only have to satisfy one part or the other. Pause the video. Okay, there's the statement. And there is the graph. So check that. If you don't understand how we got this for this video, then put a little question mark and you can ask this question tomorrow when you come to class or when I return. Okay? So here's your second one. Pause the video. Okay. And since this has an and right here, okay, we are going to have, we can write it like this. All real numbers that are greater than or equal to -3. So here's the first part of our inequality, and here's the second part of our inequality. There's the word and. So either way is okay. You can write it with an and, or you can put your variable in the middle. On the or statements, you can't do that. It doesn't make sense because we never have a variable in the middle with our symbols going this direction. We just don't do that. Okay, so you can write it with the and or with the variable in the middle, either way. And here is your graph. This is where they overlap. And with an and statement, they have to overlap. Okay, all right, moving on. Put a question mark there if you don't understand. All right, write and graph a real-world compound inequality. So a crane sits on top of a camera car and faces toward the front. So here's our crane, here's the camera car, and it faces towards the front. This is obviously the camera, and I guess this is a camera as well, like the crane goes up and down. Okay, the crane's maximum height and minimum height above the ground are shown. So here's our maximum height, here's our minimum height. Write and graph a compound inequality that describes the possible heights of the crane. Well, obviously, the height of our crane, let H represent the height, and all possible heights must be greater than or equal to 4 feet, which is our minimum value, and less than or equal to 18 feet. It has to be both. It has to satisfy both. So the inequality would be 4 is less than or equal to our height, and our height has to be less than or equal to 18. So again, we can read it like this. Our height is greater than or equal to 4, so we can read it this direction. And then we can read it this direction. Our height also has to be less than or equal to 18 feet. So we can read it both ways. And here's how we would graph our solution set. And that makes sense because that camera, that crane, can move back and forth between these two heights. It can't go higher than this, and it can't go lower than that. Okay? All right, number 3. Example, solve a compounding inequality with the word and, okay? Now, what I want to point out is we don't have a word and. We are just given, instead of being given a statement, we are given the inequality. And it is less than, notice the less thans, and if it's less than, as these two right here are, it's always going to be an and statement. Again, and means it has to satisfy both parts. So we have to find where they overlap. Has to satisfy both parts. So separate the compound inequality into two inequalities. Now look right here. We've got this middle part that has an x plus 5. So we can't truly graph this. So we're going to separate it into two inequalities and then have the word and we're going to solve them separately. So we're going to basically break up an inequality from this side over right here. And then we're going to break the inequality up from this side over and solve from here. Okay, does that make sense? We're going to break it into two separate inequalities. So we have 2 is less than x plus 5, which breaks it up to this blue section. And then we also have the x plus 5 has to be less than 9, which breaks it up into this red section. So we're going to write the two inequalities. And then we're going to solve, just like we've normally done. We've got two inequalities. We have an and in the middle, so showing that we have to satisfy both parts on our graph. So here's how we solve. Subtract 5 from each side, giving us an x is greater than -3, and x has to be less than 4. That will satisfy this inequality up here. And then here's our graph. We can put it back together. We can take the x's once we've solved for them and got them alone. We can put the x back together here in the middle. And here's our solution. You can also just leave it like this if you would like. Okay? Just know that the word and allows you to put the variable into the middle if you would like. Okay? The solutions are all real numbers greater than 3 and less than 4. With and, you will shade between the dots because that's where they overlap. You have to pay attention to where they overlap. So, since our x is greater than -3, again, the red would go this way, and the blue, the other half of the inequality, would go this way, and this right here in the middle is where they overlap. So that's what we shade. Okay? All right, example 2 and 3, guided practice. Pause the video. All right, an investor buys shares of a stock and will sell them if the change C in value from the purchase price of a share. Oh, let's start over because that already sounds confusing. An investor buys shares of a stock. So he's bought these shares of a stock. He'll sell them if the change from the purchase price is less than $3 or greater than $4.50. So it's less than, like if it goes, what this means right here is if it goes down by $3 or increases by more than $4.50. So if it drops a lot or increases a lot, that's when they will sell them. And it's an or statement, so that means only one of those two things have to apply. And it says write and graph a compound inequality that describes the changes in value. So here is our options. We're going to sell if it's less than -3, so if it drops more than $3 or it gains more than $4.50. And since it's an or statement, it doesn't have to follow both. It just has to satisfy this side or this side, so we can graph both parts, and that's our solution set. Obviously, if it drops more than $4, we're going to sell. If it makes more than $6, we're going to sell. So, all right. Let's pause the video. It says solve the inequality and graph your solution. It's a less than. So right here, here's a less than. So it's going to be an and statement. This is where we break it up. So I'm going to break it up to one side here, and we're going to break up the other side here this way. Okay, so kind of just keep that in mind. You have the blue part and then you have the red part, and the word in the middle is going to be and I always say less than is and. Less than is and. So pause the video and solve. Okay, you should have solved, and when you added 5 to both sides, you should have gotten x is greater than -2 or x is less than 9. And when you graph it, there's the middle part. There's what you graph. It's an and statement, so it has to be where they overlap, and there's the place they overlap. Okay, moving on. Here's your next one. It's a less than. So break it into your two parts. Here's part 1. And here's part 2. Pause the video and solve. There's the answer. We would subtract 4 from both sides, and then we would divide both sides by 2. And we would be left with y is greater than or equal to 3, which would be graphed this way. And then we're left with y is less than or equal to 10, which would be graphed this way. And they overlap right here. So that's what we shade. Okay. All right. Now we're going to solve a compound inequality with or. You're not going to ever see the compound inequalities with or written together because we have one going one way and we have one going the other way. And if we switch this around, again, we would have our, if we moved our variable over to this side, we would have two symbols that would be greater than. So that's one thing you can also remember is less than is and if it's greater, it's or. So, but you're always going to see the or, just saying. You're not going to ever see it written like that with a greater than sign in the compound inequality. You'll always see the or. So again, we just solve them separately. Solve them separately. So here's the original inequalities. Notice they're just copied down exactly as they are. We don't have to break them apart because they're written separately. Solve by each one. Subtract 3 on this side. And then over here we're adding 6. Hopefully everybody understands that. Okay, and then we're going to simplify. We get 2x is less than 6, and or 3x is greater than 18. We're going to divide this one by 2. We're going to divide this one by 3. And we're going to be left with x is less than 3 or x is greater than 6. So there's our answer. Since it's an or statement, we can be satisfied either on either side. Either this works or this works to make that statement true. And there's your guided practice. Go ahead and pause the video. This is an and. So we're going to break it into two separate parts such as this. Okay, so hopefully you broke it into two separate parts and you solved. And it's an and statement, so it's in between because they overlap. Okay, this one, pause the video, is an or statement though, but pause the video and try it. Okay, there's our answer. Hopefully you came up with that. You guys, you know you can always rewind and rewatch any part of this video. Okay. Last problem. Oh, and I already gave you your answer. So I want to point out something to this one though. It says solve the inequality and look closely. Remember how I said you would not have it written like this too often. But we did write it like that. It's in the greater than or greater than or equal to. So is this an and statement or an or statement? Okay. Remember, less than is and I always say it's spelled greater, but I always say greater is or. Okay. So less than is and greater is or greater is or. That's supposed to be a colon. So we're going to write this as an or statement. Again, you can break it apart and write it as an or statement. Whoops, excuse me. Let's go back. If it'll go back. But notice what happens when we break this up. Okay. What happens is the reason they wrote it this way is because, oh, I need to change this around. Okay, we can solve it like this. We can still break it up, but look what happens. We have a negative 12 here, and we have a negative 7 here. Which one's bigger? Negative 7 or negative 12? So negative 7 is bigger, so we probably actually could rewrite this one to look like this. Then it becomes an and statement, which then gives us to our answer here, and not an or statement. I kind of misled you on that one. Greater is or. Greater is or. But this one does become an and statement because we have a negative 12. We have to pay attention because as we write things, we need to have our smallest value on the left and our largest value on the right. Makes sense here too. We have our smallest value here and our largest value here. We might talk about that one. Sorry if I confused you. All right, here's guided practice. Go ahead and pause the video, do these guided practice, and bring them into till tomorrow, please.